A string is a sequence of one or more characters usually found enclosed in double quotes. There are two important things you need to know about the strings. One is that they are immutable. You can't change them once they are created, but it's easy to make new strings from parts of existing ones. The second is that you have to be careful when using two specific characters, double quotes and $signs. If you want to include a double quote character in the string, it has to be preceded with a backslash. Otherwise, the rest of the string would be interpreted as Julia code, with potentially interesting results. And if you want to include a $sign in a string, that should also be prefaced by a backslash, because it's used for string interpolation. Strings can also be enclosed in triple quotes. This is useful because you can use ordinary double quotes inside the string without having to put backslashes before them. You will encounter a few specialized types of a string too, which consist of one or more characters immediately followed by the opening double quote. For example, I'll copy and paste some of them over here, which represent or indicate the regular expression or indicate the version of a string. A version of string actually, or indicate a byte literal or a raw string that doesn't do interpolation. As you can see, you can use RVB or the keyword raw before the double quotes, opening double quotes and then closing double quotes to change the type of the string that you are putting in between the double quotes. String interpolation. You often want to use the results of Julia expressions inside the strings. For example, suppose you want to say the value of x is n, and you'll type this in between the double quotes, as we have already learned. Where n is the current value of x, any Julia expression can be inserted into a string with the $sign opening and closing parentheses construction. For example, I will define a variable called x and assign the value 42 to it, and I'll type the string above again, but this time I put the name of the variable in between $signs. As you can see, it prints the value of the variable name. You don't have to use parentheses if you're just using the name of a variable. For example, you can use the above string but without the parentheses, and it will work exactly like the command that we have already executed, as you can see. To include the result of a Julia expression in a string, enclose the expression in parentheses first, then precede it with a $sign. For example, I can type 2 plus 2 and evaluate the value of 2 plus 2 in between the opening and closing parentheses preceded by a $sign. Well, now we'll talk about substrings in Julia. Well, substrings in Julia, what is a substring? Basically, it's a smaller part of the string. To extract a smaller string from a string, we use the function getIndex, and we pass the string and the range that we want. And this is basically the syntax. I have already defined a string called s, and I'll give it a range and get a substring or part of the string. For example, 1 to end gives me the whole string, and 3 to 6 give me the word load. And I can change the range that I pass to the string, and I will get different parts of the string. And it's as simple as that. For example, over here, S3 till end minus 6 is equivalent to begin plus 2 till end minus 6. And both of them return the load of char or load of char. And this is actually a substring of the string that we've already defined. We also can use for loops to iterate through a string. But you have to watch out if you take a single element from the string rather than a string of length 1, that is with the same start and end positions, you'll get the character instead of a string. And we have to actually notice that, because it's a different type of thing that is returned. It's a character type. As you can see, one of them is ASCII character and the other one is a string of length 1. Not all strings are ASCII. To get access individual characters in Unicode strings, you can't always use simple indexing because some characters occupy more than one index position. Don't be fooled just because some of the index numbers appear to work. For example, I'll give you some examples which show you that it's not always going to work and it's not always a happy ending. For example, I define a string and a string variable su and assign some sort of string to it, and I will pass the range and test it one by one. One of them returns a character, the second index returns a character, but the third index actually is an invalid Unicode. It throws an Unicode error, as you will see. Instead of length str, using the function called length and passing the string to it. To find the length of a string, you can use the last index str. There is also a function called isAsCII, which tests whether a string is ASCII or contains Unicode characters. For example, over here I can simply pass the su string that I've already defined and check whether it's ASCII or contains Unicode characters or not. For example, if I iterate through the string that I've already defined with the each index function, you can see the third character B starts with the fourth element in the string. You can also do this even more easily using the pairs function, and you'll see that the second character actually takes more space than the other ones. In this example, I will again use the each index iterator and iterate through the string, and I will show it with the macro show at show. There are other useful functions for actually working with strings like collect, this ind, next ind, and prevind, which gives the this index, next index, and previous index, and the collect function is one of the useful ones. I will give you an example, which returns an array of characters of the string, and you can iterate actually through this array, get the elements that you want. This ind function actually does something interesting, and if you run the code with this ind function, you'll see that it returns some indexes, actually index of the start of a character, and the following indexes for a specific character which actually takes up a particular size or a particular space, that index is actually repeated. And for example, over here 1, 2, 2, 4, 5, 5, 5, 5, 5, 9, and 10. Splitting and joining strings. You can stick strings together, a process often called concatenation, using the multiply operator. For example, a string s multiplied by a string t gives you the combination or concatenation of them, which is st. If you've used other programming languages, you might expect to use the addition operator, but that is not actually working, and it will throw you an error showing that the addition operator is not working in the Julia language. So use the multiplication operator. If you can multiply strings, you can also raise them to a power, obviously. And it gives you the repeated concatenation of a particular string. For example, s to the power of 18 gives you 18 times repeatedly the string s put together. You can also use the string function to concatenate two strings together. To split a string, use split function. Given a simple string that is s over here, we can use the split function to divide the string at the spaces, returning 5-piece array. Or you can specify the string of one or more characters to split at. The characters you use to do the splitting don't appear in the final result, and you have to notice that. If you want to split a string into separate single character strings, use the empty string, which splits the string between the characters. You can also split the strings using a regular expression to define the splitting points. Use the spatial regex or regex, a string construction, or opening double quotes and closing double quotes. Inside this, you can use regular expression characters with spatial meaning. To understand what we have passed actually as a string into the regular expression type of string and passed it to the split function, you have to know the regular expression syntax, and that is the topic of a separate course. If you are interested in anything related to regular expression, just comment them down below the video so I will think about a future course. Here actually R, A, E, I, O, U, and there's a pipe character in between them, is a regular expression string. And as you'll know, if you love regular expressions, that is matches of any vowels. And so the resulting array consists of a string split at every vowel. Notice the empty strings in the results. If you do not want those, add a false flag at the end. You can actually join the elements of a split string in an array form using join function. Many functions in Julia let you use functions as a part of a function call. Anonymous functions are useful because you can make function calls which have smart choices built in. For example, split lets you provide a function in place of the delimiter character. In the next example, as you'll see, the delimiter is bizarrely specified to be any uppercase character whose ASCII code is a multiple of 8. Above, we extracted smaller strings from larger strings. But when we extracted a single element from a string, we got something like single quotes and a character in between. In Julia, these are used to mark character objects. So, single quotation, a character name. Single quotation again is a character object, but double quotation, a character. Double quotation is a string with length 1. These are not equivalent. You can convert character objects to strings easily enough by using the string function and using the multiplication operator again and a string function and concatenating the characters together. It's easy to input 32-bit Unicode characters using \U escape sequence. The uppercase means 32 bits. The lowercase escape sequence \U small u can be used for 16 and 8-bit characters. Converting between numbers and strings. Turning integers into strings is the job of the string function. The keyword base lets you specify the number base for the conversion, which you can use to convert decimal digits to a binary, octal, or hexadecimal string. To convert strings to numbers, use parse function, and you can also specify the number base, such as a binary or hex, if you want the string to be interpreted as using a number base. Converting characters to integers and back again. Int function with the capital I converts a string into an integer, and char or char with the capital C function turns an integer into a character. We can use both of these functions and show their usage. To go from a single character string to the code number, such as its ASCII or UTF code number, try this. For actually printing the alphabet quickly, we can use this one-liner. Printf formatting. If you're deeply attached to C-style printf functionality, you'll be able to use Julia macro. You call macros by prefacing them with the @. And the macro is provided in the printf package, which you'll need to load first. For example, I use using printf to load the printf package. After that, I use the @ and call the printf macro. I pass my string with a specific syntax and as the second argument the value of the pi. You can create another string using the sprintf macro, also to be found in the printf package. If you're curious about the %o.20f, this actually tells the styling of the sprintf and printf function to how to actually represent the pi value and how to print it. Convert a string to an array. To read from a string into an array, you can use the IO buffer function. This is available with a number of Julia functions, including printf. Here is a string data. It could have been read from a file. But I will actually assign a string data to the data variable. After that, we can read this string using functions such as readdlm. The read with delimiters actually function. Readdlm stands for read with delimiters. This can be found in the package delimited files. So for that, I import the package, load the package using the using keyword, using delimited files, and after that I call the readdlm package. And as the argument, I pass the IO buffer data to it. As a result, I get a 3x4 matrix, which is of type float64. You can add an optional type specification if you need to. For example, over here, I again call the function that I have called above, but as a second argument, I pass the int. So I get the elements of my matrix, 3x4 matrix, as an int64. Sometimes you want to do things to strings you can do better with arrays. Here's an example. Here I have assigned a path to the string variable s, and you can explode the path name string into an array of character objects using the collect function, which gathers the items in a collection or a string into an array. So if I call collect s, I will get an array which contains characters of the path that I've already specified. Similarly, you can use a split function to split the string and count the results. To count occurrences of a particular character object, you can use an anonymous function. For example, as the first argument, you can pass the anonymous function to the count function, and as the second argument, whatever is returned by the collect function. Although here converting to an array by the collect function is unnecessary and inefficient, here's the better way, actually passing the string itself as the second argument to the count function. Finding and replacing things inside the strings. If you want to know whether a string contains a specific character, use the general purpose in function. For example, I say in as the first argument I pass a character, and as the second argument I pass the string that I want to search inside. So the in function returns a Boolean value, true or false, whether a character is inside the string or not. For example, here I pass m as the first argument and s as the second argument. I get true because the m character is inside the string s that I've assigned to the variable s. But the occurs in function which accepts two strings is more generally useful because you can use substrings with one or more characters. Notice that you place the search term first, then the string you're looking at. Occurs in needle first argument as the first argument, haystack as the second argument, so you can remember it. Here are a couple of examples. You can get the location of the first occurrence of a substring using find first as the first argument needle and the second argument haystack. The first argument can be a single character, a string, or a regular expression. For example, I use the find first and use the string that I've already defined, that is the variable s, as the second argument. And I'll get the range that the mer string is inside the string variable s. Here's another example using the isEqual function, which returns the first occurrence of character e inside the string s. In each case, the result contains the indices of the characters, if present. Replacing. The replace function returns a new string with substring of characters replaced with something else. For example, replace Sherlock Holmes with E that is actually converted to double E, and you can use the equal greater than operator to specify the pattern you're looking for and its replacement. Usually the third argument is another string, as here, but you can also supply a function that processes the result instead of actually using the equal greater than operator to assign something that you're looking for and its replacement together. Here I use the function uppercase instead of double E, and you can see that does its job. Actually capitalizes the characters that you're looking for. But the function here, the uppercase, actually is applied to the matching substring. Replacing using functions. Many functions in Julia allow you to supply functions as part of the function call, and you can make good use of anonymous functions for this. Here, for example, is how to use a function to provide random replacements in a replace function. If you are enjoying the content, don't forget to hit that like button and subscribe for more awesome videos. Your support means the world to me.